Today we're going to be looking at least common multiple. In a previous video, you found the least common multiple of numbers by listing multiples. Well, today you're going to find the least common multiple of two or more numbers by using prime factorization. And you're really going to see how using prime factorization can make this a lot easier for you when you have very large numbers to find the least common multiple of. So let's get started. Let's review our vocabulary. So we recall a multiple is the product of a number and any non-zero whole number. A common multiple is a multiple that is shared by two or more numbers. And the least common multiple is the least or the smallest number of the common multiples. Let's look at a word problem. Trolley tours. 3 trolley tours leave from the same stop at 9 a.m. Tour A returns to the stop every 75 minutes. Tour B returns every 60 minutes. And Tour C returns every 40 minutes. In how many hours will all 3 tours return to the same stop at the same time? So we have all 3 tours, and we need to find out when they returned at the same time. Now they're going to do that several times, but we want to know the first time. So to do this, of course, this is a solution where we have to find the least common multiple. So we're going to find the least common multiple of 75, 60, and 40. In other words, tour A, B, and C. You can do this by listing multiples. However, using prime factorization is going to help you a lot more in this case. So we're first going to find the prime factorization of 75, 60, and 40. So the prime factorization of 75, we can start 3 times 25, and I'm circling my prime numbers. And then I have 5 times 5. So now I have my prime factorization, and I can move on to 60. So my prime factorization, I'm going to first notice that 2 times 30 is 60, and 3 times 10 is 30, and 2 times 5 is 10. And those are both prime. So now I have my prime factorization of 60. Now looking at 40, 2 times 20, 2 is prime, and then I have 2 times 10 and 2 times 5. So if you're not sure on how to find prime factorization, go back to the previous tutorial where I teach prime factorization of numbers using a factor tree in order to find the prime factorization. So now we have the prime factorization, and I will write that down at the bottom. So the prime factorization of 75 is 3 times 5 squared, because I have 5 times 5, which is 5 squared. And you really should write them in exponent form for this purpose. I have my prime factorization of 60, which is 2 times 2, or 2 squared, in other words, 2 to the second power, times 3 times 5. And then I have my prime factorization of 40, which gives me 1, 2, 3, which is 2 times 2 times 2, not 2 times 3, but 2 times 2 times 2, which is 2 to the third power times 5. So now that I have my prime factorization, I now can find the least common multiple using a few strategies. So in this way, I've written out step 2, which is to circle the greatest power of every prime factor that appears in any of the prime factorizations. So you see I've rewritten the prime factorization of 75, 60, and 40. And it's at make sure you write down step 2. Circle the greatest power of every prime factor. So we're only looking at the powers. Well, my highest power for 2 is 2 cubed, or 2 to the third power. My highest power for 5 appears in the 75. And then I can see that my highest power of 3 is just really the 3. So first you're looking at all the numbers that you have. I have a 2, a 3, and a 5. My highest power for 2 is to the third power, so I've circled that. My highest power to 3 is just 3. And my highest power to 5 is 5 to the second power. So I know that this is a little bit different when you're finding greatest common factor, and you really need to look at the differences, especially when using prime factorization. Your strategies are very different, and if you need to go back to the tutorial on greatest common factor and compare it to least common multiple, that is a definite possibility, and it may help you. So, now that I've circled the greatest powers, now I have my numbers to multiply. So for step 3, you're going to write multiply the circled powers. And in the previous video, you saw that we had a 2, a 3, and a 5. My highest power was to the third power for 2 and to the second power of 5. So you multiply them. Well, 2 to the third power means 2 times 2 times 2. Remember, it does not mean 2 times 3. It means 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And so then you have 8 times 3. 8 times 3 is 24, which you're going to multiply that by 5 squared, or 5 times 5. 5 times 5 is 25, and 25 times 24. I can do this quickly using the distributive property, and I'm going to model it that way because I really want upper grade students to get into the habit of using strategies to help them save time. So you might notice that 24 is another word for 20 plus 4. And if you multiply each of those by 25, you're going to get the same thing as if you used your strategies multiplying the traditional way up and down. But hopefully you know 25 times 4, or 4 quarters, is 100, and you're going to add that to 25 times 20. Well, 25 doubled is 50, and then of course add the 0 at the end. That's your 0 rules. So that would be 500. So now you have really easy numbers to add. You can add 100 plus 500 and get 600. Should have written it there first. So now that you've done that, you know that 25 times 24 is 600. So I'm hoping that you'll learn to use these tricks to help you save time. That distributive property, a lot of students want to ignore it and say that they don't need it, but it really helps you a lot. So my solution, I multiplied the circle powers, and I know that the tours all return at the same time in 600 minutes. And another word for 600 minutes is 10 hours, because there's 60 minutes in 1 hour. So I divide that by 60 and I get 10 hours, which it didn't ask you that, but most people aren't going to tell you, oh, they're all going to return in 600 minutes. They'll tell you 10 hours. So I put it in both terms for you. Make sure you have this carefully copied down in your notes, and make sure that you are reviewing any information that you need. So now let's look at some other example. Find the least common multiple of the numbers 36 and 72 using prime factorizations. So we're going to make 2 factor trees. So we have 36 and 72. Oops. Now I can use a factor tree to find the prime factorization of 36. I can start by 6 times 6 is 36. And then I notice that neither of those are prime, so I can keep going to 2 times 3 and 2 times 3. So now I have my prime factorization. Moving on to 72. 72, we have 6 times 12, neither of which are prime, so I keep going. 2 times 3, so now I have my prime numbers for 6. Moving on to 12, I have 2 times 6, 2 is prime, and 6 can be factored into 2 times 3. So now I have my prime factorization of 72. So again, I need to use those same strategies. I'm going to first list my prime factorization of 36 equals 2 to the second power times 3 to the second power. 2 times 2 times 3 times 3 is 2 squared plus 3, or times 3 squared. Then I have my prime factorization of 72. I have a 2, 2, and a 2, so 2 to the third power times a 3 and a 3, which means 3 to the second power. Now I'm going to use those same strategies. I have a 2 and a 3, and now I need to circle my greatest exponent. Well, in the 2's case, 2 to the third power is greater. And in my 3's case, they're both the same, so I can pick either one. I'm going to pick it on this side just because I know that 2 cubed times 3 squared is going to give me 72. So my least common multiple of 36 and 72 is 72. And you might say, Miss Salvador, I could do this by listing factors, but I want you to practice some easier numbers so that you understand the process before we get into the more difficult numbers. We're going to look at one more example, and if you need extra space on any of your pages, make sure that you're utilizing your space. So find the least common multiple of the numbers 24 and 30 using prime factorizations. So again, I need to find my prime factorization of 24 and 30 using a factor tree. So 2 times 12 is 24. I could have picked 6 times 4 as well. I have 2 times 6, 2 times 3. So now I see that I have my prime factorization of 24. For 30, we have 3 times 10, and 10 can be factored into 2 times 5. So now I have my prime factorization of 30. Again, keeping these separate, I have 24 is 2 to the third power times 3. 30 is 2 times 3 times 5. So I have a 2, a 3, and a 5. And now I need to circle the highest power. So 2 to the third power is the highest. In the case of the 3, it's just 3. And 5, it's just 5. So now I'm going to move that. 2 to the third power. So when I multiply all these together, I get 2 to the third power. 2 times 2 is 4. 4 times 2 is 6. Or 4 times 2 is 8, sorry. Then we have 8 times 3, 24. And 24 times 5 is 120. 20 times 5 is 100. 4 times 5 is 20. 100 plus 20 is 120. So my least common multiple of 24 and 30 is 120. Now I want you to take a minute to review your notes. Make sure you're carefully copying down your notes. And on my copy, I'm going to show you 2 pages, but your notes, you might have larger or smaller handwriting than mine. They might be 1 page, they might be 3 pages. So go ahead and take a minute to compare your notes with mine. So far I have 2 pages of notes with my handwriting. Again, yours might be larger or smaller. Take a minute to pause the video to check your notes. Now we're going to move on to finding the least common multiple of 3 numbers. So find the least common multiple of the numbers 20, 22, and 55 using prime factorizations. So let's start by factoring 20. I have 2 times 10, and 10 can be factored into 2 times 5. Make my 5 a little neater. And now I'm going to circle all my prime numbers. Now I have the prime factorization of 22, which can be factored into 2 times 11, both of which are prime. Finally, I have the prime factorization of 55, which can be factored into 5 times 11, both prime. So now I'm going to list my prime factorization of 20, which is 2 squared times 5, 22, which is 2 times 11, and 55, which is 5 times 11. So now I'm going to circle the highest power. So for my 2's, it's 2 to the second power. Then I have some 5's, but neither of them have exponents, and neither do my 11's. So I have a 2, 5, and 11 that I'm going to multiply. My highest exponent is on the 2. So 2 squared times 5 times 11 is my least common multiple. 2 squared is 4. 4 times 5 is 20, and 20 times 11 is 220. So my least common multiple of the numbers 20, 22, and 55 is 220. So I found my least common multiple of all 3 numbers without having to list multiples. Imagine having to list your multiples all the way up to 220. That would be quite tedious, whereas if you find the prime factorization and use those strategies, you can often find it faster. For our last problem, we're going to find the least common multiple of the numbers 9, 14, and 26 using prime factorizations. So let's first start with 9. Pretty easy number to find the prime factorization. We have 3 times 3 is 9. Then we have 26. Well, that's pretty simple to find the prime factorization. 2 times 13. And then we have 14. I should have done it in the other order, but really doesn't matter. 2 times 7. Both of which are prime. So you might say, oh, this is a silly one to factor out. This one's really easy. But if you look at the common numbers, this type of problem, you would definitely want to use prime factorization to find the least common multiple. So we have number 9, which is 3 to the second power. Then we have the number 26, which is 2 times 13. Then I have the number 14, which is 2 times 7. I'm going to circle my highest exponents. Well, I have a 3 squared. My 2's are both without exponents, so I'll just circle one of them. Remember, don't circle both. I have a 13 without an exponent. I have a 7 without an exponent. So these are the numbers I'm going to be multiplying together. So I have 2 times 3 to the second power times 7 times 13. And you can rearrange, because you have all multiplication, you can rearrange the order to make it easier for you to multiply. I'm actually just going to go from left to right. So this is my LCM. 2 times 3 squared. So I, of course, do my exponent first. 3 to the second power is 9. So 2 times 9 is 18. Times 7, again, I'm going to use the distributive property in my head. 7 times 10 is 70. 7 times 8 is 56. 70 plus 56 is 126. And 126 times 13 I can figure out. I'm going to do this one the old-fashioned way. So I have 6 times 3, 18, carry the 1. 3 times 2 plus 1, 7. 3 times 1 is 3. Hold my spot. And I have 1 times 6, 1 times 2, and 1 times 1. I add up my totals, and I'm going to do this in a different color for you so you can easily see it. Nice bright red. And 378, 1260. Or hold your spot with an X as well if you want. 13, 6, and 1. So my least common multiple of the numbers 9, 26, and 14 is 1,638. And I know this is a little messy, but I wanted to keep it all on the same page so you can keep looking at all the steps. So imagine having to list numbers up to 1,638. That would have been very tedious, very difficult. That's your least common multiple. So I hope this shows you how using prime factorization can save you a lot of time, especially when you have more challenging numbers to work with. Remember to check your notes, and I'm going to show you my notes, and you can compare yours to mine on the next page. So take a minute to review your notes. You can always pause, rewind the video anytime you need to, and compare all the pages of your notes. So this is the last page with the last two problems that used finding the prime factorization, finding the least common multiple using prime factorization of 3 numbers. Go ahead and pause the video and compare your notes to my own. So great job today taking notes. Remember, these strategies will help you save time. I've modeled the distributive property as well, which you should start to get into the habit of doing when you have large numbers to multiply. It'll make it easier for you at times. And remember that when you're finding the least common multiple, listing out all the multiples of numbers is not always the best strategy. Finding the prime factorization is a great strategy that can help save you time.